I thought this was a tricky question. I'm going to start by doing it with some numbers to get a feel for it. So capital P, capital Q. Let's imagine that there are 11 in P because we're told that there's more and they're both odd, and then 7 in Q. So what I can see is if I give 2 to Q from P, they'll end up with the same amount, 9. So if I give 3, then I'll have more in Q. So that would be the answer in this situation. But how are we going to do it when we've got P and Q, not just 11 and 7? Well, if I find the mean of the two values, that tells me how many I would have in each if I shared them equally. So if I then do 9 minus 7 to give 2, that tells me how many I have to give from P to Q so that they have the same number. So if I then just add an extra one, that tells me how many I have to give to have more in Q than in P. All right, and that is a good basis for the general problem. It's going to work in the same way. It's just harder to see this because, when we're working algebraically. So now I've got little p and little q. The mean is going to be p plus q over 2. See, p and q are both odd, which means when I add them, I get an even number, which means p plus q over 2 is a whole number. So I can give that amount. Now, if I go with this mean, and I minus q from it, just like before, that would tell me how many I have to give from p to q so that they have the same amount. If I then add an extra 1, then I'll have more in q. So I just need to now write this clearly as a fraction over a common denominator of 2. P plus q over 2 minus 2q over 2 plus 2 over 2. I'll just put them all over a common denominator and I can bring it together. P plus q minus 2q plus 2 all over 2, which will become p minus q plus 2 over 2. So where is the answer? It's going to be B. All right, well done on your efforts here.